Wow. That's great. So the schedules actually says we should go ahead and do a coffee break or whatever, get some glass of water or whatever is suitable at your side at the time. And I would suggest that we meet in what is good, 15 minutes or so.
Okay, everyone aboard. Next participant is Brad Nelson, who will present us another ColorForth version.
All right. Yes. Can everyone see that?
Yep.
Great. Okay. So I'm going to talk about yet another ColorForth implementation. Why ColorForth? It's a fun dialect invented by Chuck Moore, and it uses color tags to dispatch, which I happen to think is actually a tremendous simplification of how forths are usually implemented. And I think that it is fascinating to think about how to make forth even simpler. And I think it's actually kind of a powerful idea. As is common, I guess, with ColorForth talks, a note about color. One thing I often think about whenever I explore something in this space is there are actually a few folks in the Forth community that are colorblind and that actually have challenges seeing the ColorForth colors, including our friend Dennis Rufer, who actually does a bunch of things in ColorForth. So as I worked on yet another ColorForth, I got to thinking about the color palette used. And so I've got a few things that I haven't had a chance to run it by him yet. There's an interesting color scheme that ostensibly is more visible to a range of folks with color blindness that I'm curious to run by him. But a more basic idea that I had that I've been playing around with is to just use a scheme that doesn't emphasize red green, which is the most common type. And I've actually found that having used it for now about a week, that in some ways it grows on you. The ordinary ColorForth scheme is very harsh, and so I'm sort of trying to lean into using that scheme, and we'll use that in this talk. I may run this one by him, which is sort of understandable to folks acquainted with the typical colors, but this is the one I'm going to try for this talk, and maybe it will grow on you. I'd be curious what you think in the chat comments. In any event, so ColorForth, as folks know, uses color to distinguish certain operations like defining a word. So here we're defining square, and then we just provide its definition with compiling each word at a time. And then we can then execute that word using yet another color type. And really what's nice about ColorForth is that you can keep things even simpler, and you can make sure you understand all the pieces. And I wanted to, for this particular implementation, focus on making something that was maybe a little bit more than a toy, but we'll see. And as I guess folks have noticed with some of my forths, I tend to try to start with a small kernel, oftentimes in C, bootstrap, and then get into forth as quickly as possible. So, and I'm still just calling it CF for now, but I probably need a better name, as there's starting to be a profusion of these. For the moment, my implementation is runnable on Windows, but I'm trying to keep that complexity kind of all pushed to one side, because I'm really just using Windows as a host to get me an environment where I can access the keyboard and the screen. But really, I just want to do raw x86 64 instructions. And what I have in mind is maybe to make this UEFI bootable, because in a UEFI environment, there are also some drivers that are in place that open up access to a wide range of screen types and a wide range of keyboards and so on. And one other reason that I've structured things to sort of get into Forth quickly is that I'm able to use that to defer most of the register convention choices to code that's in Forth. And then the other kind of slightly weird thing with this implementation is I've ended up using what's called an X32 addressing scheme, where you use 32-bit addresses, but 64-bit data. So the data stacks and so on are all 64-bit, but when you do loads and stores, they're 32 bits. Addresses are done as indexes multiplied by 4 bytes. And this keeps things compatible with sort of Chuck's and Howard's ColorForth encoding convention. And it also is helpful because a lot of the things that you want to access, like pixels, are oftentimes 32 bits, and so all very useful. I've tried to use Chuck's quirks as much as I can sort of bear. Some of them are a little hard to get in your head, things like minus sign for invert or as XOR. If you've seen some of my prior talks, a thing that I realized I had mushed together in my understanding of the existing of Chuck's ColorForth was his use of if and minus if. It turns out that on the Pentium version, he sort of leans into using the flags on the system rather than the top of stack, whereas I had looked at some of the GA144 documentation and assumed that that was sort of the definitive behavior where the top of the stack is used to make a decision. But it turns out that in addition to not having if consume a value from the stack, at least in his Pentium implementation, it's typically looking at either the zero flag or the sign flag. Bunch of the other conventions, load and store being word sized is actually pretty handy and grows on you. I've tried to use an A register as well. And then there's also this transition of emitting a literal and immediate transition from immediate words to compile words. And so the way that Chuck built his ColorForth, I think, is that he wrote his editor and his core system in assembler, and then built up the rest of the system in Forth sort of once he had an editor. I've taken a slightly different approach. I devised a text syntax that lets me commit my changes to a source control repository and use a conventional editor. And then I've written a converter that converts in and out of the binary format. My eventual goal, and I'm actually at the stage now, is to not typically be editing things in Vim, but to have this as a way to be able to continue to use conventional version control. And then using that minimal ColorForth, then using a minimal ColorForth that I implement in a very simple C interpreter, I'm able to bootstrap ColorForth, and then the rest of the system is itself written in ColorForth. And then I provide a few sort of syscall-like entry points back into the Windows host environment to do things like to bit blip the screen and to get keyboard events and very small handful, like 5 or 6. And then I wrote an editor, which I'll be showing off. The ColorForth encoding, I've kept the binary encoding where strings are encoded using 28 bits of sort of a variable length encoded characters, and then a 4-bit color tag. Numbers share the color tag, but then also use a single bit to indicate hex and so on. And then my converter, I used a convention of a prefix to specify transitions to the different words. This makes it possible to load up in Vim with a certain syntax plugin and be able to see things. I've started using this less as I now have a ColorForth editor in ColorForth, and there's a bunch of prefixes that I use to mark decimal and hex. So all of this is at this point kind of a little bit vestigial, but also I've kept it around because I want to be able to have snapshots that I can save to version control. I've used the color mapping, and I'll toggle the color coding here just so folks that are familiar with conventional coding, the coloring scheme. I've kept the tags more or less the same. I've actually followed through on dropping the uppercase and all caps comments, and more or less retain the scheme as is. Let me flip back. And then I've noticed there's actually two different character sets that are out there. Howard had actually ended up using this character 41 as a colon, but I've kept it as a tick, which I noticed that the ArrayForth implementation seems to use because it's useful to be able to do apostrophes and so on. The converter is a beast of a thing, considering that it's just converting from a binary format to text and back and forth, but it's 253 lines of Python and supports both Chuck and Howard's images, and I use that to sort of vet that I got the encoding right. And you can run the thing at the command line. I made a plugin, as I mentioned, for Vim to be able to show the highlights or show the colors as I edit things. And then to Bootstrap, what I do is I start with a C interpreter that only knows how to execute words out of the dictionary. So it understands the dictionary format enough to be able to traverse the dictionary, look for a word, and then it invokes it using a thunk that it assumes is also available in the dictionary. So it looks up the C to fourth thunk, uses that to call any words that it wants to execute. And that thunk makes the transition from the standard C calling conventions for x86-64, which have particular registers that are sort of well known, and transitions into the register convention that I use inside of the system. And that handles both transitioning in and transitioning back out. I actually start ColorForth up on a separate thread because eventually, once the system is running, I don't want to ever leave ColorForth. So I transition in and then just stay in after it's sort of past the bootstrapping stages. And then using this sort of C harness that knows how to just execute words only, I then implement compiled words, which the harness knows how to use a separate thunk to invoke based on the color tag. And then lastly, a compiled numbers thunk. Well, I should mention, I don't actually implement the wide number words that Chuck has for big numbers. And this means that I can't have constants that are larger than basically 7 hex digits, what fits in the it fits inside of a packed word. And this is just another simplification. So, and then I build up all the core words in the macros. I implement color words and dispatch, and then I transition into the machine code interpreter, and it runs from there. And so these are the only words that the harness understands, the sort of compiling in a 1, 2, or 3 byte value. It knows how to do a load and a through operation. It knows how to switch between the two different vocabularies, the fourth vocabulary and the macro vocabulary. It knows how to do numbers. And then I found that for debugging, it was absolutely necessary to have a print operation, which just pops up a message box. And it's occasionally useful to see the here value. This is about a third of the interpreter. This is the part that implements the dispatch to those different words. So sort of complicated, but not too bad. The ColorForth words are encoded just directly here. I use my converter offline to take these words here and convert them. I've kept Chuck's register convention with a few twists. I use RAX and RSI the same as he does for the stack. This ends up being surprisingly handy. I still have mine to eventually switch to something where I could have a wraparound stack the way Dr. Ting did with a 64 values and a data stack, but I have found that Chuck's choice of RAX and RSI is handy because then you can use the string words, and they have some nice properties in terms of not perturbing the flags. I use RDI as a code heap pointer, which is a little bit wasteful, but ends up also simplifying the bootstrapping. And then I use R8 because I'm on, remember, x64 to keep a pointer to a bunch of the internal variables shared with the host harness, including the place that I park the stack pointer when I transition in and out. I use the RSP as the return stack pointer, obviously, and share that with the C stack. And then I also use, similar to Chuck, use RDX as the A register. And so I've got a little bit of a structure that I keep around for interacting between the two layers. Won't go into it, but there's a bunch of the entry points to the different system calls. The dictionary, I use a slightly different format from Chuck. Rather than using two separate arrays with words and addresses, because I'm operating in 64 bits, it ended up being handier to have 32 bits for the address and 32 bits for the word, and then be able to interleave them and then walk down a single dictionary going up to a 0 to mark the front. The editor is modal. It's inspired by sort of a mixture of VI and Chuck's ColorForth editor. Similarly, it does word at a time entry. There are things like color toggling and search that are sort of specific to editing ColorForth. It borrows the wonderful idea that's in the ColorForth editor for doing the clipboard as a stack, where when you delete a word, it gets pushed into a stack, and if you paste or you can pop it back off of the stack, which works quite nicely. So on the keyboard that I use is a little non-conventional. I reassign some of the typical keys so that I don't have to do any modifiers. So there's no shift keys for anything, but I do use a QWERTY keyboard, and I've replaced some of the keys like brackets and slash and so on with the characters in the ColorForth character set. So it looks like this. And then in the editor, I use these same keys, but in a modal interface to let you do different operations. So there's movement keys, mimicking the VI movement keys. There's keys for moving page at a time, keys for toggling shadow blocks, which I'm reluctantly using. I've never been too much of a fan, but I decided to cave and give it a solid try. Toggling blue words on and off, although they're not blue in the color scheme that I've chosen, as you'll see in a moment. And then words to input the different colors, and then the words to toggle a color, words to change the base, and then copy paste. I borrow the convention from Windows of X, C, and V being copy and paste, except there's just a single key press in that mode. A couple random things I'll mention. I've struggled a bit with magenta variables. They have a lot of quirks as it stands. Magenta variables have the property that one really weird quirk is that you really can't give them very long names, because they make the assumption that the next word over is the word in question. The other kind of inconvenience I've noticed implementing an editor in ColorForth is that if I have magenta variables in the source code, now when I move them, I'm potentially damaging the editor and confusing the thing that I'm using live. So for this reason, I ended up more often typically using a conventional, and I'm going to flip the colors here so that you can, those that are familiar with the conventional colors, doing a definition followed by a yellow word to put something into a data heap, and then using a green word to then transition that into a literal, and that ends up being more convenient because the variable isn't sitting inline in the source block. I'm still tempted by some of the desirable properties of magenta variables in terms of being able to save and load their state directly in the source code, but I found in practice it's very tedious. And let's see. I've also found the flag conditionals a little bit hard to get sort of in your head. it's sort of nice that they leave the stack alone, but it's hard to compose them because now you're sort of dealing with the flags. I think I may in the future give some sub talk just on this topic. It's kind of fascinating, but you know, you end up with these strange idioms like wanting to do an or drop to check to see if a value doesn't match something, or oftentimes you'll end up you know, having challenges composing things. So you could do a pattern like dupe 3 or drop, and then a conditional, and then another layer to kind of compose conditions. So there's some quirks to it that I feel like I haven't really gotten comfortable with. And I think an extra quirk that I found is that when it comes to signed and unsigned comparisons, Chuck uses this word less, which he actually defines with a whole bunch of, it's actually a whole chunk of code that manipulates flags. It's actually kind of overly complex, and yet minus if works most of the time. So there's a whole sort of interesting sub question around how to do, how to deal with flags and how many of them are sort of minimally necessary. So anyways, I'm going to go do a demo because that's the main thing I wanted to show off in this talk. So I've got the system here, and it's bootable like this, and of course it decides to open on the other monitor. Let me open this up, and so here it is. It has an interactive editor similar to the conventional one in ColorForth. There are shadow blocks where I've got my to-do list, and you can do sort of conventional things. So if I wanted to enter a definition, I can hit a key, enter square and dupe and multiply, and then I have square, that type of thing. And then I have my my stack for copy paste, and I can readily copy paste things around. Oops. And just to give a brief tour of the system, so here's that C to fourth word that is all just sort of a bunch of assembly done in line to be the thunk transition into ColorForth from the C calling convention. And then I bootstrap with a word that knows how to compile a word that compiles 1 byte. And that gives me just enough to be able to implement semicolon, which then gives me just enough to be able to implement compiling a 32-bit value into the code dictionary. And then I'm able to implement comma compile, at which point now I can compile words. Although I don't use that quite yet, because I then go ahead and implement the rex w prefix. I do implement this peculiar word nip dupe, which I then use to implement dupe. And then I'm able to implement literal. And now I can compile literal. So I actually have kind of most of the conventional things. And I'll toggle the color scheme here just so folks get a visual sense of that. I got a couple other things. By the way, I've noticed that the more I've used these other color schemes, I'm starting to find the conventional ColorForth scheme a little bit visually harsh, as you may find. I've also got a black and white scheme in here, by the way. Let's see. Let me go on. And then I go implement a bunch of macros, similar to what Chuck does for all of the core things. More macros, and then the conditionals, and I then copy a bunch of them over to compiled copies. And at that point, I go ahead and I implement a few more things, some thunks to be able to transition and call in to see this word invoke, which looks very complicated, does the reverse trampoline of getting back into a Windows call from inside of Forth, but passing along a bunch of parameters, which allows me to implement a handful of system calls, including things like posting a message to the main thread, getting an event, and reading and writing some things. And then this is, now I'm implementing the ColorForth dispatch in just two blocks. So this is an implementation of defining words, compiling numbers, executing words, executing numbers, postponing words, this conventional cyan words, variables, and then a none slot. And then that lets me define this table to dispatch the 16 different tags. And then I can have a loop that evaluates things. And I should mention, by the way, I've avoided using most of the conventional looping structures. I've ended up using tail call for basically everything. So I don't even have a for loop in this system. Everything is done with relying on doing semicolon followed, or a word followed by semicolon, which gets converted into a jump. I define blocks as being multiples of 256 plus some value, magic value outside of from the trampoline variable area, and then that lets me implement load and through a second time inside of the interpreter, which now lets me start the main interpreter. And from this block on, everything is now just running in ColorForth. C is out of it except for thunking over to draw pixels on the screen and get key events. And then I implement a bunch of additional stuff. I implement box drawing here, a stack to keep my a graphic stack to keep some of the state that I want to be able to toggle back and forth. And then you'll notice this terrible font I'm using, and I do intend to have a better font soon, but for now, I've actually got this screen actually defines this font. And if you can imagine, the font is implemented in 25 bits. So there's 4 bits horizontally and 6 bits, or 4 pixels horizontally and 6 bits vertically. And then the uppermost bit will optionally clone the rightmost column onto the leftmost column, which for a few characters like the letter M and the letter W and the letter X give me a wide character so that I can get some of those shapes right. So it's just a barely readable font. And then I have words to implement, printing of letters, and I have a mapping from the key codes in Windows to ColorForth colors. And I have printing of numbers, printing of, let's see, this is sort of code for the managing the input loop, and drawing of a prompt. And this is printing of letters and numbers. This is the input prompt and a bunch of other stuff. And then here's the editor. With each key sort of specified and its behavior, and then I hook it up or sorry, this is a little bit more to the editor. Then here's the main dispatch table for navigation in the editor, and here's the color themes and a bunch of fun stuff. Anyways, let me show you some cool things you can do. Here's a fun word. One of the things you can do with ColorForth is you can have inline words that are in conventional ColorForth, they are blue. I'll show it here. And what they do is they get executed in the editor. And so here I have a word called forth that just draws the ColorForth logo inline, and you can inject those characters where you like. I have here's a text dumper. So I have a dumper that can I can view the raw bytes in memory and move around and see those. Let me go back into the editor here. And then I start up the world. Let me show one other thing, and then I will take some questions. Here's some more fun stuff with that ColorForth word. I've got some words to change the font size, so you can do fun, interesting things with font size. And then here's a couple here. I've got an implementation of factorial that I need to actually load this block, and then it will sort of print that. But you can do actually even better if you go into this block. I load it and go into the editor. This prints the squares, but prints them inline using blue words. And then similar story, but I was inspired by the use of Fibonacci to do the Fibonacci words, numbers, and here they are in line. in a blue word. And with that, I will take some questions.
Yes, I do have a question. What is your terminal emulator?
So this is implemented in ColorForth. So this is the outer code in Windows is giving it the opportunity to draw into a just a Windows into a window from a piece of memory. At startup, the Windows harness will actually allocate a gigantic chunk of virtual memory, I think a gigabyte of memory, way more than I need. And then what's happening is that for every frame, it needs to, let me go show the code here. It's calling into this this flip method, which does a post message over to the main thread in Windows, and then copies that buffer to the screen. And so I'm actually drawing the pixels. And that is why I have this terrible font, is because I am actually implementing the font in ColorForth. So the entire environment you're seeing here, with the exception of the startup of the window and the initial bootstrapping, is all done in the ColorForth that is in the environment.
So in essence, you implemented your own terminal emulator.
Indeed.
Wow, that is cool.
Mm-hmm.
Are there other questions? Flipping the color schemes here. Let's see, what are some other fun? One of the things that I think is also kind of nice about having a custom editor is the ability to toggle things out. Like suppose I wanted to comment out this word, I can just toggle each of these to a comment, and then I can toggle them back.
I have a question.
Mm-hmm.
Can you change the color scheme for this? Because I personally find that, let's say, bright green is more readable than, let's say, dark blue.
Mm-hmm. So the color scheme is actually defined. Let me find the block here. There's a notion of toggle. There's a button that toggles the Q button toggles color schemes, and I put in these 4 color schemes, but you could certainly add others. And I actually vary several things within each color scheme. So you'll notice that in this scheme that uses the Wong colorblind themes, they're kind of a more muted set of colors, and then some of the things are bold. And then in this one, I decided to do, this is the conventional ColorForth colors, and I picked wider characters. And then in this purely black and white theme, I've got sort of bold, large characters for the definitions, and then narrower ones for yellow, and then a sort of a gray for the others. And so you can kind of pick and choose. And actually, let me show in all of the theme. Oops. And so in this theme, for example, I do italic for the. It's more of an oblique, actually, technically, for these, and I keep that also in the more conventional scheme. So. I initially, I share your sense that initially, the conventional themes are nice. I really do find this I encourage folks that are playing around with ColorForth to play around with the themes. At first, I was like, oh, this is a sad muted color palette, and then I gradually grew used to this one, and then I started playing with this one, and it grows on you. It's sort of now even the other one feels a little harsh. So I find that it's what you adapt to, but what I really need to do is run this all by Dennis Rufer, because one of the things I wanted to do with the scheme was to find one that made this a little bit more accessible to him, without resorting to sort of introducing stray punctuation characters and so on. Other questions?
Yes. Can you maintain these codes without any comments of sorts?
This is a good question. So I do feel like the level of comments I have in here, and if I swing back to my first block, make shadow blocks more detailed. One of the things that Chuck does in his forths is he uses shadow blocks, and I'm toggling here back and forth between the shadow block for this one, and you'll see here it gives a commented description of the block, or maybe a better example would be this one, where it's got sort of the comments hidden away. I personally have not typically been a big fan of this style of thing with the shadow blocks, but I noticed that it is kind of nice to be able to sort of see things in a mode where the comments are largely absent, although here there actually are comments to show the x86 instructions. But I share your sense that one of the nice things about being able to have comments interleaved is actually to have these nice white comments inline. And so, for example, let's see, the stack effect here. Following Chuck's convention, I've put the stack effect in the shadow block rather than in the definition. I'm still on the fence about whether it's good or bad. Well, ask me again when I've not touched some section of it for a month and then try to look at it and understand it. So, good question. Christian?
Yes, Brad. My question is very basic. I've seen so many people talking about ColorForth, and they all say it's a very clever implementation of Forth. And I'd like to know what makes it so clever. Why is it better than any other implementation?
So I think, let me see if I can capture it with a sort of visual picture. So this screen defines a bunch of dispatch words where these are just, you can think of them like a conventional Forth with colon definitions for the meanings of a few of the different each of the major colors, and then you just have a table. And so I think what is appealing to implementers of Forths about ColorForth is that ColorForth really is just load a value from memory, look at the bottom 4 bits, dispatch that word based on the bottom 4 bits in the tag, based on this very sort of simple sort of definition of how to interpret each tag, and then that is your entire Forth implementation. And so in some sense, like these 2 screens is the entire implementation of the system. And so I think it's appealing because if you compare it to a conventional Forth, you oftentimes are sort of in a conventional Forth, you're chasing your tail, fighting with the challenge of parsing the source code at the same time that you're trying to interpret the source code. But with ColorForth, the parsing work gets done in the editor, and now all that you're left to do in the interpreter is just tear off a tag, execute it, tear off a tag, execute it. And so it's a very, very simple sort of core system, if that makes any sense.
Mm-hmm. Very great explanation.
Thank you, Brad.
Brad, I have another question. Chuck also experimented with keyboard layout and things like this. Do you stick to his way of assigning the keys, or maybe
I do not fully. So I'm not a fan of the Dvorak, and so what I do have a QWERTY style scheme, but I do use modal editors. So there are some similarities. So for example, in Chuck's editor, he also uses a row of keys for motion, but he actually flips the ordering of those keys versus VI, which bugs me to no end. And so in VI, that row of keys, the up and the down, are reversed of what Chuck uses. So I have flipped them to the VI direction because I'm not likely to be able to change. But I've kept the convention that the row, the key to move a page forward and backward is below the key to move left and right. I moved to where the shadow block key is, and I think aside from that, I've kept the space bar and as the terminator key, and that actually really grows on you. That I think of all the things in the ColorForth editor, that idea of using space bar as sort of an enter key is actually a very effective thing. So I would say mostly not, except for arrow movement a little bit and the space bar. So.
Yeah, I see. Thank you very much. Yeah, Philip, no, George Philip, you have a question.
Yeah. Hello. I have question, Brad. So is there a way to export import block? Like how to share your
Yeah.
code?
So actually, that you're reminding me of a thing I forgot to demo. So I actually have over here in this files 1 and 2. I actually have both one of Chuck's ColorForths and then Howard's. So let me I can go ahead and load those. I'm going to load file number 2 into block 200, and I will load to a bunch of bytes of it. That's how big it actually is. And then if I go to edit that, oops. So if I skip forward here, so this is the raw junk at the front of Howard's implementation. And then I don't know what's going on there. There's some interesting things. If you get far enough forward, you get, and now this is actually Howard's ColorForth implementation loaded in here. And so he's got a bunch of blocks. So he's got quite a bit of code that he implemented over the years to do all sorts of things. So you can load and save blocks that way. And then in general, the system, there's a save operation that will save the current set of things. I'm still sort of working on that because all of these I rely on transitioning out to Windows to do the reads and the writes for it. And I'm trying to keep as strong as I can a partition where I don't want to create a very detailed contract between Windows and Forth. I want to basically treat it like it's just a bootstrapper because as I mentioned, I have in mind the idea of switching this to being something that you could actually boot up as an OS and use UEFI to provide the screen and the keyboard and the disk. Although it's frightening. One of my laptops recently did an upgrade. It is amazing how complicated the BIOSes have gotten now that they have UEFI. They're practically an operating system of their own just in the BIOS now. So. But actually, you may have had a slightly different meaning, which is the idea of importing and exporting to a more conventional form. I mentioned I have this converter. Let me show that very briefly. So the
Python.
Yeah. So the Python converter can be used, and so for example, here is the same boot blocks viewed as text. This is just the color you're seeing is just syntax highlighting from a Vim plugin that I made, and so you've got the same content, but you'll notice that there's these prefixes that specify the different color transitions. So this colorize utility, which will let you convert back and forth between ColorForth blocks and text, which makes it nice to be able to check things in and out.
Right.
All right. Thank you.
Yeah, thank you very much. What good progress! I've seen your talk at Silicon Valley a month ago or something like this, and you made a huge progress. Wow, yeah, that's really great. Yeah. All
May
right.
I ask one last question?
Sure, Christian, welcome.
Brad, the original ColorForth could boot from a floppy disk directly on 8086 hardware. Could your implementation work without Windows and boot directly from the hardware?
So yes and no. The challenge is that so in its current form, there's a Windows dependency, but I've designed that transition to rely on Windows very little. There would need to be a little bit of an outer thunk to transition in that would need to be implemented to boot up. And I think one other challenge, and this is one of the reasons I've been thinking about UEFI is that an issue that Chuck ran into with his Forth is that he ended up having to assume particular hardware in order to be able to implement in assembler his own loader, whereas there's a range of different graphics hardware out there, a range of different keyboards. UEFI provides an environment where there are some very simple syscalls that will let you switch graphics modes, let you access the keyboard, and so on. So I think that there is a fairly straightforward path to being able to boot using the UEFI BIOS bootloader. But Chuck is doing sort of the booting off of the conventional, like classic BIOS, which really gives you nothing other than loading one block of code. And for that, there's quite a bit of work that you would have to do that I have not done. So yes, if it was a sort of a more complex bootloader like UEFI, which is available on basically all conventional machines, but no, if it was on a sort of an older style classic BIOS. But none of that is working yet. So grain of salt. Like I'm speculating about a thing I have not yet hit all of the obstacles of trying.
Thanks.
All right. I think we're at it. Thank you very much again. And yeah, it's Cornelius time, I think.